Okay, graphing systems. A system of equations is more than one equation, and we're going to just work with graphing systems today. There's other ways to solve systems of equations. Graphing is just one method. So let's look at the first one on your lesson. Now, I know this name is different than the name that's on your lesson sheet. Your lesson sheet says Quaid. So however you want to read it. Alfred graphed these two equations, meaning he graphed this system of equations. Looking at his graph, what is the solution? So what do you think? If you were to look at that, you may not understand what a solution is, but take a shot at what you think the solution might be looking just at the graph. Back. 3/1? No? Anybody else want to take a guess? Paola?
2/1?
Where are you guys looking? What are you looking at? Tell me what you're looking at. Where they intersect. Okay, you just may not be sure how to say it. Okay, so the solution to the system is where the two graphs intersect. Now, you know from last week that in order to graph each of these equations, you had to solve for y first, right? So you solve for y, you graph the two equations, and you look at where they intersect. Well, in this case, they intersect at +1, +2. So the ordered pair, 1, 2. That's the solution. So wherever they intersect is the solution to the system. So number 2 says, it's just that ordered pair for that point right there. That's all it is. Okay, Alfred wanted to check to see if his solution was correct. How can he do that? How can he check to see if 1, 2 really is the solution to these two equations up here? We see visually on the graph that it's the solution because it's where they intersect. What if he graphed it wrong? How can we check? Cece? Plug them into each of the equations. So this is your x and this is your y. Okay, so let's start with the first one right here. So that says -x. So I'm going to put -1 plus y is 2, is supposed to equal 1. Well, -1 plus 2 is 1, isn't it?
Yes.
So it works for that one, but it has to work for both equations. So let's try the next equation. The next one says 2 times x. Well, if x is 1, 2 times 1 is 2, plus, what's y? 2. It's supposed to equal 4. It does. 2 plus 2 is 4. So how can he do that? Plug in I'm going to put x and y, or you can plug in the ordered pair. Okay? All right. So number 3 says Mary graphed this system. She thought the point of intersection was 2, 10. Was she correct? We don't have a graph to look at, so how are we going to see if she was correct? We're going to plug in 2 for my x and 10 for my y. So let's start with the first equation. I'm just going to write it exactly as I see it. 3x minus 2y equals -14. Okay, x is 2. So 3 times 2 minus 2, and then my y is 10, times 10 equals -14. Okay, 3 times 2 is 6 minus 20. It's supposed to equal -14. What's 6 minus 20? -14. So guess what? -14 does equal -14, doesn't it? Yeah. So do we just stop and say her solution is correct?
No.
No, because it has to work for both. So we have to try this other one. -2x plus y equals 8. So -2 times 2 plus 10. -2 times 2? -4 plus 10 equals 8. -4 plus 10 is 6. Does 6 equal 8?
No.
No. So was she correct?
No.
No. She was not correct. So she must have done something wrong when she was graphing. So you can go and check all of your answers that you get for your intersection by, you can do it mentally if you want. If it doesn't say to show your work, just mentally plug them in and see if it works. Then you'll know that you did it right. Okay? All right, so we're going to solve this system by graphing. Well, the first equation is good to go. It's already solved for y. So remember, we start with our y-intercept, which is -5. So we want to go down 1, 2, 3, 4, 5 to -5, and we put a dot. That's where we're going to start. Then our slope is 3, or 3 over 1, which means from this -5, you're going to go up 3 and write 1. And then do it again. Up 3 and write 1. Up 3, write 1, up 3, as many times as you can. And draw your line and make sure you put arrows on the ends, please. Okay? Now we're going to do the second one. But before we can graph it, what do we need to do? Solve it for y. So we want to get y by itself. So we need to get rid of the 2x. How do we get rid of the 2x?
Divide by 2.
No. Subtract 2x. Okay, so we're going to minus 2x on both sides of the equal sign. Bring down the y equals. And then how do we write 5 minus 2x? Because we don't write 5 minus 2x. And we cannot do 5 minus 2 because 5 does not have an x. Aaliyah?
-2x plus 5.
Very good. -2x plus 5. All right, so we're going to start at +5. Okay, and then because it says -2 or -2 over 1, we're going to go which way?
Down.
Down 2, right 1. You can also go the opposite direction. Instead of down and to the right, now you can go up and left. And that would fill in another spot for you so you get the line as straight as possible. I kind of went off there, sorry. And then circle where they intersect. Circle that point of intersection. That's the solution to the system, which is what? What's that ordered pair?
2, 1.
2, 1, right? You guys see that? That's 2, 1. Whoops, that's not very neat. Okay, 2, 1. That's the solution. We could plug that in to each of the equations and it would work. Okay? All right, let's look at the next one. Now, we don't see a y-intercept here, so what is our y-intercept?
0.
0. So we're going to put a dot at 0, 0, and then our slope is going to be what?
Up by 4.
Up 4
Over 1.
to the right 1. And then we could also go backwards and go down 4, left 1. Try to make your lines as straight as possible. Should have had some rulers out for you, sorry. All right, and then let's do the next equation, but before we can graph it, we're going to need to do what? Solve for y. So we're solving for y. So what do we need to do first?
Subtract 2x.
Subtract 2x. So we have -y, not just y. A lot of people will forget that minus is with the y as a negative. Bring down -y equals, and -2x minus 2. Very good. We're not done. We don't want -y. We want +y. So what do we need to do? Divide by -1. It would be the same if you multiply 2. Divide by -1 all the way across each term. Okay? So we end up with y equals
2x plus 2.
+2x plus 2. My pen is acting weird. So we start where?
2.
At 2, and then we move
Up 2 and over 1.
up 2 and right 1. Good. Over's not a real good word. I need direction. Like right or left. There you go. So, my solution to my system is what?
1 and 4.
1, 4. Questions so far? Aaliyah.
How do you find out your solution?
Your solution is where they cross here, and that's an ordered pair. That is at, to get there from the origin, you go right 1 and up 4.
Oh, okay.
Cece?
Can you notice a negative line, like on the equation or whatever? Like, is it whenever the whole thing is negative or whatever?
What do you mean a negative line?
Like it's going down.
The slope would be negative if it's going down.
So if it's like negative plus minus 2, like if that would be the 1 or whatever?
Whatever number is in front of the x, if that's negative, the line will go down because that means it's a negative slope every time. Yep. All right, take a look at this. Matt, or in your case, David, graphed a system of equations and got the following graph. What is his solution?
There's
There is no solution. These are what lines? Parallel. Are they ever going to intersect?
No.
No. So, in this case, no solution. Those are easy ones. Okay? All right, let's go ahead and do this one. We may skip the next one just for time. Okay, let's graph the first one. So we start at what?
3/4.
Negative 2 is our starting point. Remember your y-intercept.
Yeah.
Then from there, what's our slope?
Up 3/4.
Up 3 to the right 4. Or down 3 and left 4. Right?
Yes, ma'am.
Oh my goodness, that was terrible, that line. All right, and now this other one, we need to solve for y first, so we're going to add 3x to both sides. So you have 4y equals what?
3x minus 8.
3x minus 8. Okay, then we need to divide by
4.
4. Each term gets divided by 4. So we have y equals, can 3/4 simplify?
No.
So leave it as 3/4 x minus 2. Good. Okay. So graph that. Oh, what do you know?
It's all the same.
It's the same thing. So where is that going to intersect?
-2, 0.
It's the same line. This is the same as this. So it's infinitely many solutions because it's going to be it's the same line. It's just intersecting at every point. So yes, that's infinitely many solutions. Okay, we're going to skip number 8 just for time. All right, let's take a look at this. So here's the different types of answers you may get when you are solving systems. You may get an ordered pair, okay? That's when you actually, they intersect and you actually get x comma y as an answer. Okay, there's one point of intersection, okay? That's referred to as an independent system. You might get no solution. That's when the lines are parallel. That's considered an inconsistent solution, or system, excuse me, an inconsistent system. And then infinitely many solutions is when it's the same line. That's considered a dependent system. Each line is dependent on the other because it's the same points all along. Okay, so you have to do a little sketch here. Pretty easy. One solution, draw 2 lines that intersect. That's all you have to do. Draw 2 lines, and then I would just circle where they intersect. Doesn't matter where you put them on there. Just 2 lines that are intersecting. No solution, what would that look like?
Parallel line.
2 parallel lines, and you can put them however you want as long as they look parallel. And then all real numbers or infinitely many solutions. And I usually just kind of make it a little thicker just to kind of make it obvious that it's just the same line. Okay? Okay, these last two are pretty simple. We're graphing x equals -2, so you're going to go on the x-axis to -2, which is right here, and the line goes vertically through the -2.
Oh, I see.
So that's all you do. If it's x equals, you go to that value and draw a vertical line through. Y equals, you go to the y-axis, to that number, which is right here, and you make a horizontal line that goes through. And it's pretty easy to see where they intersect for the solution. Where do they intersect?
2, 4. No, 4.
-2, +2.
We make
Negative
two
two.
dots on the line.
-2, +4. You don't need to put a dot. You can just draw a
Oh, I
line.
was thinking how much you go over.
-2, +4 is where they intersect.
Oh, I see.
But you do need to graph it, okay, so that you understand that if it's x equals, it's going to be vertical, y equals is a horizontal line. Okay, let's do this last one real quick. So y equals 4, so we go to the y-axis, be careful, up to 4, and don't draw a line going straight up and down, because that's just going to be on the y-axis, right? It needs to go through the 4, and then x equals 3, go to the x-axis, and it's going to go through the 3. And so that would be at
3, 4.
3, 4. Those are pretty easy. Okay?
I never can remember. Okay, this is 4-3.